8 grams of CH4, that is methane, occupies 11.2 dm cube at s.t.p. What volume would 22 grams of CH3CH2CH3, which is propane, occupy under the same condition? Solution. Now the first thing to do here is to determine the molar volume of the gas at s.t.p using the information given for methane gas. And to get that, we have the formula to be moles equal to volume over amount at s.t.p. This amount at s.t.p can also be referred to as the molar volume of the gas. So now here we are given the volume of the gas to be 11.2 dm cube, but we do not know the number of moles. So to proceed with this, we need to determine the number of moles of methane gas so as to get the amount of the gas at s.t.p, that is the molar volume of the gas. So here now, to get moles, we say moles is equivalent to mass over molar mass. So the molar mass of methane CH4 equals, we have one atom of carbon present, that's 12, the atomic mass of carbon, plus the atomic mass of hydrogen is 1, and we have 4 atoms present, so that's 4 times 1. So this gives us 12 plus 4, which is equivalent to 16 grams per mole. So now, for the moles of CH4 now, we have the mass to be given as 8 grams divided by 16 grams per mole. And this gives us 0.5 moles. So now, coming back to our formula here, that moles is equal to volume over amount at s.t.p. So we've gotten the moles and we've been given volume from the question. So amount at s.t.p now will then be equal to volume over moles. So the volume of CH4 is 11.2 dm cube. So we have 11.2 divided by 0.5. So this gives us 22.4 dm cube. That is, the molar volume of the gas is 22.4 dm cube per mole. So that is 1 mole contains 22.4 dm cube. Now let's say that, so let's quickly go back to the question. So the question says that what volume would 22 grams of propane occupy under the same condition? Now the condition is that 8 grams of methane now has a molar volume of 22.4 dm cube at s.t.p. So now, under this condition, what will be the volume of 22 grams of propane? So now, that means we've gotten the amount at s.t.p using same formula. We've gotten the amount at s.t.p for propane, that is the molar volume of the gas. The number of moles is what we'll be calculating, while the volume will remain unknown. So to proceed, the next thing to do now is to calculate the number of moles of propane. So now saying that moles equals mass over molar mass. Molar mass of propane now that is CH3 CH2 CH3. So combining this together, we have C3H8 will then be equal to, we have 3 atoms of carbon present, so we say 3 times the atomic mass of carbon is 12 plus We have 8 atoms of hydrogen present, so and the atomic mass of hydrogen is 1, so we have 8 times 1, so this gives us 36 plus 8, which is equal to 44, and the unit grams per mole. So now we've gotten the molar mass of propane, and from the question we are made to understand that the mass of propane is 22 grams. Then we say moles of propane, so I'll just say C3H8 now, equals the mass now 22 grams divided by 44 grams per mole, and this gives 0.5, the unit moles. So now coming back to the previous formula showing the relationship between volume and the molar volume of gas, so we say moles equals volume over amount at s.t.p. Since both methane and propane are being placed under same conditions according to the question, now the amount at s.t.p. now can be made to be 22.4 dm³ based on what we've gotten earlier. So now the number of moles of propane, now we've gotten that to be 0.5. So now it will be very easy for us to calculate the volume of propane. So now we'll say volume equals moles times amount at s.t.p. and volume of propane equals the number of moles, which is 0.5, times the amount at s.t.p. gotten from the previous calculation, 22.4. So this gives 11.2 dm³, the unit. And this is the final answer. From what we've just did now, we can say that under the same condition, the volume of 22 grams of propane is 11.2 dm³, and that will be all on that. Kindly subscribe to this channel and as well click on the notification bell for you to be notified as soon as new videos are being posted. Thank you.